All right, so now we're graphing sine, cosine, cosecant, and secant with our transformations. And so the first graph is just a sine graph, so no asymptotes here. And then we're going to answer these questions. Make sure you fill the window and round your curves. All right, so first note I make to myself is what the parent function for a sine curve looks like. This doesn't take long to do and makes it more likely that you won't accidentally make it a cosine curve or something. So, all right, so the amplitude is 2. That's the number in front of sine. The period is, if there's a number in front of x, it's 2 pi divided by that number. There's just a 1 in front of x, so the period is 2 pi. The phase shift is, there's nothing to factor out in front of the x, so it's to the right, pi over 2 units. Sometimes I like to make a note of like, what is pi over 2 units? So take a look at the scale here. Pi over 2 units is 1 box. So shift everything 1 box to the right. Is there a midline other than 0? Yes, there's the shift of down 1. So the midline is y equals negative 1. So let's draw our midline through negative 1. And I also want to do the phase shift. Like you can either draw a new y-axis, or some people just put in like a little, like this is my new origin kind of thing. I've had students do this in the past, which I kind of liked. If you don't want to have all these dotted lines all over the place, especially when you do a graph that has asymptotes, sometimes drawing an entire axis can get confusing. So here's our new 0, 0. And then now I've taken care of both shifts. All I have to do is sketch in the sine graph. So the sine graph starts on the origin. I know that's hard to see because I just put a thing there, but origin. And then the amplitude is 2. So the next, I need to divvy up the period before I get into this, so that I know how often the points are plotted. So if the period is 2 pi, remember you would have normally gone from 0 to 2 pi, but shift that to the right 1 unit. So you're going to have a point here, cut that in half, cut that in half, half. So we should have, when the period is 2 pi, we should have a point every pi over 2. All right, so anyway, back to my sine graph. So plot at 0, 0, and then the next point is 2 units above the midline, 2 units below, midline. So we start on the midline, we end on the midline. So here's one sine curve. And now that I have one period, I just need to keep going. So 2 units above, midline, 2 units below. That's going to carry me off of this window. And I'll just indicate that it would go up from there. And then 2 units below midline, above, midline, below, midline, above, midline, below. And if you're right-handed, I had an art teacher tell me it's easier to draw left to right if you're right-handed, so that's why I'm starting on the right there. It's also easier to draw down than it is up for most people. So that's my first graph. All right. There's this extra thing here. It says, try writing a cosine equation for the graph in number 1. We talked about on our first day that sine and cosine are just horizontal shifts of each other. So find a section of the cosine curve. Remember, cosine looks like this normally. So you could pick out a positive cosine curve if you wanted. You could look at one like, here's a cosine curve. Looks like it's been shifted pi units to the left. Or you could pick out like a negative cosine curve here. There are a lot of different answers that you could come up with for this one. So I want to go with no shift. I'm going to go with a negative cosine curve. So I'm looking at this thing right here. This is my cosine curve. And I'm going to draw that. So that's a negative cosine. So it would be negative cosine. It's got an amplitude of 2. It's got a period of 2 pi. So there's just an x there. There would be no horizontal shift because it's starting on the y-axis if I make it negative 2. So it would just be cosine x. And there would be a midline shift. It has the same midline as the sine graph, so there'd be a minus 1. So this is just one option. If you did the positive one back here, like from here to here, you could say positive 2 cosine. There has been a shift. I would consider this like it would have started here. So 2 boxes to the left is pi. So how do I go left? I do plus pi minus 1. There are a lot of different answers. Like I said, you could pick any two. That's actually what we're doing after this quiz, is writing. These are called sinusoidal functions. So we're going to come up with these equations for sine and cosine. Just sort of a preview. Okay, what about this one? This is y equals negative cosecant. So I need to graph a sine curve. So I'm going to graph sine and then put in some asymptotes here, right? It's one of these. So let's just start going through everything. So I don't see an amplitude here, but the amplitude I should make note of is 1. And actually, you know what? It's a negative sine curve. So let me get my negative. Negative sine looks like that. The period is, let's factor a 1/2 out of this first, sorry. Factor a 1/2 out. That would leave you with x minus pi. That'll make the shift easier. So the period is 2 pi divided by 1/2, which is 4 pi. The phase shift is to the right, pi units. And how much is pi? That's 2 boxes. And then domain and range, domain and midline, I want to get the domain after we do our problem. Y equals 0 for the midline. There's no vertical shift. All right, so first divvy up the period. So put a mark at 4 pi. And then everything's going to shift to the right pi units. So extend this out a little bit. Pi is about 2 boxes. So really we're going to end at 5 pi. And instead of starting at 0, we're going to start at pi. So here's your distance for the period. Let's erase our mark at 4 pi. So cut that in half. So halfway would be 3 pi, right? And then don't want that tick mark there actually. Cut that distance in half, 2 pi, and then another 2 boxes. Okay, so here are where our mark's going to go. And then we're doing a negative sine curve. So I'm going to do this dotted. So here, here. So midline, below, midline, above, midline. So here's the sine curve that we're going to use. All right. Now, you can continue this on. I would just continue this on, actually, and then put in the cosecant curve afterwards. So we're going every 2 boxes now, right? So if you want to put little tick marks for yourself to keep your eyes in the right position, you can. After we're on midline, on the y-axis, we go up, and then midline, down, midline, up, midline. Oops, no, sorry. My last 2 points, I went 1 box instead of 2. At negative 4 pi, we're back up. All right, and I'm just going to do my dotted part in here. And then we put in our vertical asymptotes. So anywhere that the sine graph that you just drew is equal to 0, that's after horizontal shifts. Anywhere it's equal to 0, or goes through the midline, maybe we should say, that's where you get a vertical asymptote. And then we sketch in the curve. So the one point you know is on the graph is that anytime that the sine graph is at 1, and then we're just going to kind of draw in these curves. And negative 1. The rest of these points we're estimating in, and just kind of make it fit the width of the vertical asymptotes here. So something like this. If you didn't draw this other half here, that's okay. Technically, you just need to fill the window. So what is the domain? You can use your graph to help you with this. Although it is a good idea to figure out how to solve these algebraically too, because what if you messed up your graph? And then not only are you getting points off for your graph, but your domain is wrong too. And sometimes on the AP test, instead of graphing the whole thing, they might just ask us about the asymptotes. So you can solve for this algebraically. You set the parentheses equal to what's on the parent function. Where are those original, where are the original asymptotes? So this would take a little bit of studying. The original asymptotes are at pi k, and k is an element of the integer number set. And so you would need to solve for this. So to solve for x, you would add pi over 2. So now it's pi over 2 plus pi k. And then to get rid of the divided by 2, you would multiply everything by 2, including the k term. So this would become pi plus 2 pi k. And then double check your graph to see if that works. There is a vertical asymptote at pi, check. We add 2 pi to get to the next one, check. And we could do that any number of times. So yeah, that works. You could also get this expression from your graph. Pick any one of these asymptotes to start off with, add the distance between two asymptotes, and toss a k on it. So x is not equal to pi plus 2 pi k. Make sure you write k's somewhere. All right. Take a look at this graph. This is a cosine graph. And it's a positive cosine graph. So it's going to do one of these. So this is the general shape I'm going for. And I want to factor. Anytime you see an expression like this, you want to factor it out. So that makes this 2 times x plus pi over 2. The amplitude is 1/2. The period is 2 pi divided by 2, which is pi. The phase shift is to the left, pi over 2, which is 1 box. You don't have to do 1 box to get points. That's just a good reference. And the midline is y equals 0. So we don't need to sketch in a new midline, although we are going, to need to shift things. So the period is normally pi. So if I shift that to the left, pi over 2 units, the period's going to end here. And instead of starting at 0, it starts here. We need to cut this period into 4 equal parts. So cut it in half, cut it in half again, half again. So these are each at pi over 4s. And then draw in a cosine curve, which is 1/2. So has a height of 1/2. It starts there. And then it hits midline. And then it goes to negative 1/2. Midline, positive 1/2. Now this is a cosine graph, so we don't have to do asymptotes and all of that. So now we know that we're going to mark every little half box. And I honestly need to put these tick marks in for myself so I don't skip. You can see I skipped in that first problem or something. I skipped over somewhere. So you don't have to fill these in ahead of time. I just like to. I do want you to fill the window though. So this is just one period, and then we're going to keep going. Midline, below, midline, above. Midline, below, and you just keep filling it in. So all of the work is done getting that first period in. And then you're trusting your pattern and going from there. Now, if you had extra time on a quiz or a test, you could check these values. These are all common angle values. So for a lot of these, you could do a quick little speed quiz and double check to see if I plug in 2 pi, am I getting the answer that this says I should get? So I'm trying to round these, trying to be correct on my concavity. As long as you are curving your graph, I'm not going to be too picky about it, but you would get points off if you just did this or very loosely sketched things through. You need to plot all of the points that I'm plotting. Okay, the next graph. Oh, wait, sorry. Try writing a sine equation for number 3. So, okay, find a chunk of a sine curve. So find one period. First one that's catching my eye is right here. Here to here, that curve. So what's happening to that curve? It's a positive sine curve. It has an amplitude of 1/2, just like cosine. It has been shifted and it has a different period. So let's see. So the period should be the same as cosine. That'll always be the case for these. So whether I write it sine or cosine, I need a 2 in front because the period's pi. So there's that. And then this has been shifted to the right, pi over 4. So if I want to make that happen, I do x minus pi over 4. And that's all in parentheses. And the midline is 0, so nothing to add on the end. This is just one example. Again, you could pick anything to start. Lots of different options. All right. Last one, I think. Yeah, last one. So now we have a secant graph. It's a positive 2 secant. So I want to start with a positive cosine graph again. I'm going to start with that. The period is 2 pi divided by 1 because there's a 1 in front of the x, so just 2 pi. The domain, you know what? Let's do domain to start. X minus pi should equal pi over 2 plus pi k kes. This is from our notes the day before. This is from our notes yesterday. This is where the parent function has asymptotes. Add pi to that. So if I add pi to pi over 2, I get 3 pi over 2 plus pi k. So that should be, what x is not equal to. So all reals, x is not equal to 3 pi over 2 plus pi k. Now, isn't that equivalent to pi over 2 plus pi k? I think so. So there are a lot of correct answers for your domain as well. So this is just mathematically what this would come out to. All right, so phase shift. There is a phase shift to the right, pi units, and for me, that's 2 boxes. The midline is y equals 1. There's a vertical shift here. So I'm going to draw in my midline. Actually, so let me do this. Instead of drawing in my whole midline across, well, actually, no, I do still want to do that. Sorry. I still want to do that because when I go fill the window, I like to be able to see that I'm hitting the midline. What I was going to say was because I have a phase shift and a midline, I was just going to say I was going to draw the little cross here for my new origin, right pi up 1. But that's fine. I'll just put that there. So now I've got everything set up. I need to draw in the period and mark off the 4 equal parts. So the period starts at pi and it's a period of 2 pi, so it should stretch out to 3 pi. And cut that into 4 equal parts to place your points. And then draw a cosine graph to begin with. It's a 2 cosine graph, so I should begin 2 units above the midline, and then I hit midline, and then I'm 2 units below the midline. So at 2 pi, you should be at negative 1. Midline, above midline. So here's 1 period. This is my sort of like stencil so that I can get in my secant graph. And then remember what we did for cosecant. Let's just continue the cosine graph so that we can quickly fill in asymptotes and secant curves. So now that I see the pattern, I'm going every 1 box, and I'm just going to continue down. So midline below, that ends me on this side. And then midline below, midline above, midline below, midline above, midline below. Dot these in. You don't have to, excuse me, you don't have to sketch in the entire curve. It's just what I like to do. Now we're going to put in vertical asymptotes. It's not where our vertically shifted graph is hitting 0. It's actually where our graph is hitting the midline, because the midline is what would have made cosine equal to 0, and then we shifted it up. So you're always connecting back to the midline. So there should be vertical asymptotes going through. Remember, we said all of the pi over 2s is, excuse me, is basically what this is saying. All right, and then sketch in your curves. Don't forget about the little half ones on the end. And remember to put in arrows. Getting the actual secant part, I mean, this is the easy part, right? All the legwork is done in plotting the sine or the cosine graph. So it's really important that you know how to do those with period and phase shift and new midline or a vertical shift. And then the actual secant or cosecant part, that's easy. You just have to remember to do it. All right. If you would like more practice with this, just let me know. Come into office hours. We can kind of make up these problems pretty easily.